Bismillahirrahmanirrahim. Today we are starting uh, 2.2 section of chapter 2, and here we will discuss some maximum and minimum values of a quadratic function. So generally we write a quadratic function as a x square plus bx plus c. Here a, b, c are the constant. If a is not equals to 0, then we have this quadratic variables or x square available. So this is called a parabola. So this quadratic equation draw as a parabola. Orientation of parabola depends on the value of a, the coefficient of x square. So if a is greater than 0, then if this coefficient is positive, then we have this kind of parabolic structure, while on if a is less than 0, then we have this kind of parabolic graph. So here we have a maximum value, or here we have a minimum value. So maximum and minimum points can also called turning points or stationary point. So symmetry exists in parabola. This is also a feature of a parabola. Please for further learning about these concepts, example 2 on page 28 could be revised. So here we have exercise 2.2, the symmetry of each quadratic function to find the maximum or minimum point. Sketch each graph showing all axis crossing points. So we will solve all these problems in this 2.2 or exercise 2.2. So we are solving question number 1b. So here 1b is y is equal to x square minus x minus 20. Y is equal to minus x, x square minus x minus 20. So we can write this expression in this form as a x square minus 2ah plus ah square plus k. So we can say that a is equal to 1 by comparing from here to here, and minus 2ahx minus 1. So we can put the value of a here, get the value of h like this, and similarly ah square plus k. So a and h values are being used from here to get the value of k, which is this. So we can write this parabolic shape in this form. So this form becomes this one. So we can draw the shape of parabola using this form of parabolic shape. So here at x is equal to 0, the y will be minus 20. So we have one coordinate 0 minus 20. At y is equal to 0, then this expression becomes this. So plus 9 by 2 and minus 9 by 2. Taking square root on both sides, so we have these values. So one is a plus, the second one is for minus, and x has values 5 and minus 4. So x-axis crossing points are 5, 0 and minus 4, 0. 0 means x-axis is crossing. At x-axis y is always 0. Y-axis crossing point is 0 minus 20 as discussed earlier, At x is equal to 0, y is minus 20. So y crossing point, this is y crossing point, this is x crossing point. X crossing point means y is 0, y crossing point means x is 0. Since a is greater than 0, the minimum point is hk. For this graph, this h and this is k. This is h and this is k. So the minimum point is hk. So this is the minimum point. So we can draw it. This is minus 40, this is 50. So the midpoint is between minus 5 and plus 5. This is 0.5. So this is 0.5 and this is 0.5, the minimum point. And this is minus 20.25. So here we have this 20.25. This is at x is equal to 0, y is equal to minus 20. So this can be seen from this equation. And x is equal to 0, y is equal to minus 20. It is also plotted here. So we have 4 points, this one, and the minimum point. With the 4 point, we have drawn this parabolic shape. Similarly, for the other examples, let's do this 1D similar kind. This is 1f. Here we can see that the coefficient of x square is minus, negative. So we can compare this by this equation. So here we have a is equal to minus, that is less than 0. So minus 2ah is equal to 2, and ah square plus k is 15. So we have obtained value a, h and k as this by comparing coefficient and by solving all these things. And we can write down this a, h and k at this place to write this parabolic shape in this form, which is this. So this is the form of y. So at y x is equal to 0, y is this. So one of the coordinate is 0, 15. At y is equal to 0, x is equal to this one, and taking square root on both sides, so x minus 1 is equal to this. And from plus side and from minus, we have these two values, 5, 0 and 3, 0. At y is equal to 0, we have two value of x, and x crossing point is 5, 0 and minus 3, 0. Y crossing point is 0 and 15. A is less than 0, so we have this kind of thing. 3, 0, 5, 0 means average value is at 1. So this is the mid distance between these 2 points, and here at this point hk, which is 116 from here, this is 1 and this is 16. H and K. So this is a maximum point because A is less than 0. This is 1f. For problem number 2, express this in this form. So we have this and we have to write it in this form. So we have done it like this, x minus n square plus n. So this can be write down like this, comparing coefficient minus 2. So here we have 1, and 2m is equal to minus 8, m square plus n is equal to 0 because no coefficient is there. So this is 1, So m is this and n is this. From m and n we can place m and n here. This is x minus m plus n. So we can write it like this. So similarly for the other equation, b, c, d, e. There's so much problems that we can see here. On problem 3a, we have to write in this form, this equation into this form, and we can write it like this, and we just compare coefficients to get the values. So m and values. So by placing it in place of m, we write this. In place of n, we write this, and this form. Similarly for the others. This express the following in the form as this. So we have to write this in this form. So here we have ax minus b square this. So we open it like this and this. By comparing coefficient, we can see a is equal to 2, minus 2ap is equal to minus 8, this, and ap square plus q is equal to 3. So we will get this a, p and q by solving. First a, place a here, get the value of p, and p, a and p is here, and get the value q. So once we get the value of a, p and q, we put the value a, p and q here at its respective positions. So we get this structure into this one. Similarly for the others. We have to express this equation into this form. So we will write down in a expanded form, and we will compare these values. So here this is same. So 2n is equal to 6 and m minus n square is 0. So this is n, and from n we can place it n and to get the value of m, and by just getting this n and m, we put these values m and n here, and we get this shape in this one. Similarly for the other problems. Now problem number 6, express in this form. So this part has to express in this form. So we will expand it like this, and we'll compare it from coefficient to coefficient. So by on comparison, we have this minus 2b is equal to minus 2, and a minus b square is equal to plus 5. So we get the value of b from here, and by putting this b value here, we get the value of a, like this. So once we get this a and b value, we put this here at its respective place to get the form in this shape. Similarly for the other questions. Express in the form of this. We have to express this in this form. So we have to expand it and then compare coefficients to get the values like this. So here we have p is equal to minus 2, minus p is equal to minus 2, and minus 2pq is equal to minus 6, and a minus pq square is equal to 9. So from p, we substitute p here, get the value of q, p and q are obtained, placed here, and get the value of e. Simplification. So on getting p, q and a, We put the values at its respective position A, P and Q. A, P and Q. Similarly for this one. Now this question number 8, here we have to express this in this form. So we'll expand it first like this, and we compare the coefficient like this, and from this we have A is equal to 4, and by substituting A here we get the value of B here, and by getting A and B place it here, and we get the value C as this, and by putting these values at respective position we have this form, which is our required shape. So does the function this meets x-axis? So we solve it at y is equal to 0, the function will meet x-axis. Since roots are complex, so it shows that it will never meet the x-axis. We have to prove, but we have obtained this in a complex shape. So whenever we have a complex solution, means x-axis roots are not possible, will never meet x-axis. This function will never touch the x-axis. So from equation fx is equal to 2x minus 8, we have to express this in this form. So a, b, c are the integers, so we'll expand this in this form and we'll compare. On comparison, we have obtained a, b and c as this. To find the coordinate of a stationary point on the graph, we actually put the value is equal to 0, we call it, we have the stationary point at H and K, which is also a turning point. This H and K is a turning point. So we have these stationary points. Question number 10, we have fx is equal to x square minus x minus 5, and x belongs to real numbers. Find the smallest value of fx and corresponding value of x. So for this we have to shape it like this. So in this form we have hk, which is 0.5 and 5 to 5. So this is the minimum value, because here we have the coefficient of x square is positive. So this have a negative smallest value is a turning point, and this is the smallest one. We will solve the other parts in the other classes, in other some other time, once we complete the other parts. Fx is equal to this and fx in this form. So we have to write this function in this form. So we will compare it and we'll solve it. Compare, and by comparing this p and q, we placed it here and we have obtained this in this form, and range of this is 11 1 by 8, because this is the value which is maximum possible. Is 12x. So we'll draw it here some other time. This for this to this. So we will compare it with in this form. So we have obtained turning point is H and K, this is H and this is K. This is turning point. Secondly, this is minus, so this point is maximum. This is we have to write this in this form, so we will obtain like this. We will solve other parts in some other way. So in this way we have completed our topic 2.2.